Here we'll do an example of a multiplication combination. Here we have the same system as in the previous video, but now we're asked to find fx times hx, or fh parentheses x. Anytime you see fh with these two letters written directly next to each other, like I'm underlining now, that represents multiplication. So you will not always see a multiplication sign, but two letters sandwiched together inside of the same parentheses represents multiplication. Once again, we'll begin by writing down fx and hx with a multiplication symbol in between. Now we'll place the correct functions in the correct positions. Fx is 2x minus 3. We place that in the first position. Hx is 1 divided by x plus 5, and we'll place that in the second position. We now have 2x minus 3 multiplied by 1 over x plus 5. Now, if you have a polynomial times a fraction, we're going to make sure to multiply that polynomial times only the number on top, the 1. We will distribute that 1 to both terms inside the parentheses. Now, 1 times 2x will give 2x, and 1 times negative 3 will be negative 3. This will still be over x plus 5, but notice we did not multiply the 2x minus 3 times the denominator. However, if fx had been a fraction itself, we would multiply the numerators together and multiply the denominators together. However, since fx was not a fraction, we were only multiplying by the numerator. There's no need to simplify this any further, and so we can say fx times hx is 2x minus 3 over x plus 5. We can also write this as fh parentheses x, with the fh sandwiched inside that parentheses. Now that we have our combination function, let's think about the domain. Remember that we are looking for roots, denominators, and logs. We don't have any roots, we don't have any logs, but we do have a denominator, that's x plus 5. So now we'll say x plus 5 is not equal to 0 because the denominator rule says the denominator cannot be 0. If we subtract 5 from both sides, we'll end up with x not equal to negative 5. We'll draw a number line. We'll place the infinities on the left and the right. We'll recall that not equals to gives us an open circle anytime we draw it on the number line. We place that open circle at negative 5, and that will split our domain into a left-hand piece with this left arrow I'm drawing now, and a right-hand piece which I'll draw toward the right side. We'll label that piece A and piece B. Piece A will go from negative infinity to negative 5, and piece B will go from negative 5 to infinity. We'll place a union symbol in between them, and this will give us our domain of our new combination function.